Hi, today we will solve this N-ary tree pre-order traversal. You might have already come across some kind of problems like tree or tree traversal problems like pre-order, post-order, and in-order for binary trees. This is specifically to N-ary tree and pre-order traversal we need to do in this problem. N-ary tree is nothing but you will have in case of binary tree, you will have only two child for each and every node, maximum two child. It might be 0 or 1 or 2. In N-ary tree, it doesn't matter. There is no restrictions in the number of child for a particular node. It may vary from 0 to any positive number. So if you have more than two child for pre-order traversal, you need to visit the root first and then left to right order of the childs. You can go through the problem statement. It is pretty straightforward and simple. So this will be your input. This is what the expected output. The output is like you need to visit the root first and then go for the left node or the leftmost child and then visit this node and then go for the leftmost child for that particular node. It will be 5 in this case. So 1 3 5 we have visited. So now return back to the next child of 3, so it will be 6. So we completed visiting child nodes for node 3, so we'll return back to 1 and the next child for 1 is 2, so this will be 2 and 2 doesn't have any child, so we'll return back to 1 and then we will go for the next child, that will be 4. So the output is pretty simple. So this looks very complicated example, but the logic remains same. We can check one or two iterations here. So first we will visit the root, sorry, here this is the input, right? So we'll the output is 1 and then we will go for the leftmost child, that is 2. It doesn't have any child, so we'll return to 1 and then the next child is 3. 3 is visited and for 3 6 is the leftmost child, so we will go to the 6 and 6 doesn't have any child, so we'll return to 3 and then again 7. So you can go go forward and check whether the output is correct or not. The logic remains same even it is a binary tree or it's an N-ary tree. uh, okay, so let us first see what is the method signature looks like. We are supposed to return a list of integer and we are getting input only the root value. Yeah. So now directly jumping to coding, just think of the logic here. If you are from the CS background, you might have already got some clue that we will be using some kind of recursions here. But how the overall structure of this code looks like, we are going to return a list. So anyway, we have to create a object of list. We directly cannot create a list object here because list is kind of an interface, I guess. Need to go for array list or linked list kind of stuff. So in this case, I'll use array list. It's pretty simple. uh, you can go for linked list as well. If you are really worried about data uh, data structures like time complexity and space complexity, linked list looks better here. Okay, we'll use linked list only, but in the recursion method what we are going to write, what all the input you need to pass that recursion method. If you create the object of linked list inside this method, for every call of that recursion you need to pass that list as well. If you create outside, it will be available to all the methods, need not to be passed in every call. Either approach will be fine. So instead of going for class object, we'll create inside this method. This will be our result. So result will look like, we cannot create the list object, so linked list we will take. Now pass what we need to do is we need to call the recursion method, or to be simply put, the name we will take it as recursion logic, or any name what you prefer. And you need to pass root of this tree, and along with that the list that you created, and at the end you need to return this result. We will define this here. We are not going to return anything because we are just adding the values to this linked list, and our root is of type node, and the result is of type list of integer. So first you will see whether root is null or not. If it is null, straightforward you will return from this method. If it is not null, then we will put that result, I will put that root value in result, and then we need to go for child nodes from left to right. How will you get the child node? So each node will have a list of children here. We need to fetch this list and need to traverse that. Okay, how will you traverse this list? We can simply go for each loop here, node child from root node dot children. So we will traverse each child from left to right. The order will be maintained in this list. Uh, you need to go for recursion for each and every child again. So this is the method that we will be calling again. Instead of root, it will be child. I hope this will work. Nothing explicitly needed here. If it doesn't have any child, it will be null, or this for loop doesn't work. Should we check that whether root.child is null or not. Mm, Let us run this code and see what is the result when root.children is null. So we got the expected result. We can check with this input. So custom test case run. I think we got the expected result. We are good to go for submission. We can check the other test case, like if there is only one root or only one node in the tree, whether the test case will be a pass or not. Yeah, it works. What in case if it is one null? It's an invalid test case. We need to have other node here. What is wrong in this example? Why is this invalid test case? Should we have null again at the end? Why only one node doesn't work? Was there a comma at the end earlier? Hmm. Okay, anyway, we'll submit this. It is accepted. We'll go for more results, and we are here. And there is another best solution for this. We'll see that what they are doing is they are using array list, and all the logic looks same, but still our solution was more, it was taking more time than this. I'm not sure why, but uh, linked list is better to use in this case, I feel. Why did array list work better than linked list is the question. Even I don't have an answer right now. Okay, You can try with some other different approaches if you have. You can try without using recursion and see what will be the time complexity and where you stand in the result. Okay, all the best. Thank you.